Guys doing today? I am going to try this chain rule lesson. I'm going to try to teach it to you through this video. I hope that it works and that you're able to kind of follow along with what's going on. We'll see. I'll give it a shot. I'll probably go through the first front page here, questions 1 through 4, and then kind of see how you're doing with it. And then, on the back side, go through the first 2 examples here, and then kind of give you the chance to practice and then maybe make a second video with the practice answers. But let's give it a shot. So we've been doing derivative. We've seen the power rule that we've had, product rule, and quotient rule. And now this is something called the chain rule. This is the one that we probably will use most of the time. It's basically a rule for finding the derivative when we have a composition of functions. Here you can see f of g of x, something like this, right? F of g of x. And it's the ability to take that derivative. And here's how it looks. The derivative of f of g of x is f prime of x, f prime. So you're taking the outside function's derivative, leaving the inside alone, and then multiplying it by the derivative of the inside. This is sort of that chain that keeps happening. You'll see it a little bit more with trig. We'll have like a trig chain rule day, and there'll be multiple little chains here. I'll try to draw the little chain so you can see it. So here's an example of a problem that we did the old way. We have y equals x squared minus 2 squared, and the first thing you need to do is actually, the way we were doing it before, is multiply this out. So I'm going to show you again how to do this part, which I think you already know. We're going to write it as y equals, and then this part right here multiplied out would give you x to the 4th, and then minus 2x squared minus 2x squared, which is minus 4x squared, and then finally plus 4. And now when we take this derivative, so if I were to do dy dx, hold on, let me try that again. There we go. It's even better. Equals, all right, this mouse is kind of, I'll try it with my regular mouse. You're going to hear some clicks. I apologize about that. 4x cubed, and then minus 8x, and then plus 0. So that's the old way to do this derivative. Using the chain rule, what we're able to do is take y equals, and then we have this function. I'm going to rewrite the original. X squared minus 2 squared. And we're going to do the power rule, but when we do it, we're just doing the outside derivative first. So we're just ignoring the inside. So it's 2 times, I'll call it y prime. 2 times the outside, which there's a 1 here, so that's just 2. And then the inside stays the same, x squared minus 2. And then this exponent is to the 1 less, so it's just 1. You don't have to put it here if you don't want to. But then we need to multiply it by the derivative of the inside, so times the derivative of the inside, which is just 2x. Now, to spare me from having to multiply all this out, I think we can do this in our head here. 2 times 2x is 4x. 4x distributed in will give you 4x cubed, which you can see is right here. And then this 4x, the 2 times the 2x times 2 would be 8x, and that's the second part right here. So you can see the answers are the same. Chain rule is great because if this exponent right here is something that is larger than 2, like let's say it was raised to the 5th power, you wouldn't have to multiply this out 5 times, and all you'd have to do is just multiply the exponent 5 in front, leave the inside alone. This is important. You always leave this inside alone to the 1 less power, and then multiply by what's on the inside. So this would be, if this were a 5 here, this would be 5 times x squared minus 2 to the 4th times 2x. The only thing that would change would be the 4 here and the 5 here. All right, let's take a look at the next example. We'll do some chain rule with this next problem. And again, I mean, the chain rule is pretty much your power rule, but when you're doing your power rule, you just have to always be aware of what's on the inside of the function. So if I were to look at 4x squared plus 1 to the third, we're going to take this exponent, multiply it out in front, so we have f prime of x equals, this is 3, leave the inside alone, 4x squared plus 1 to the 1 less, so this would be a 2, and then times the derivative of the inside. The derivative of the inside, always put it in parentheses. This will just be 8x. We've talked about simplifying answers, and this answer does not need to be simplified. You can just leave it like this. Really, the only thing you probably could do is multiply the 3 times the 8x, make it 24x, put it in front of this. But, you know, this could also be FOILed out, but I wouldn't worry about it. All right, on to number 2. Same thing. We've got the inside function. So this is, when we talk about inside and outside function, f of g of x, the g of x is this thing inside. The f of x is just the function 2x to the fourth. But the x on the inside is more than just an x. It's this thing. So to do the chain rule here, we're going to multiply these two things. So f prime of x is equal to, and we're going to have 8, and leave the inside alone, x to the fourth minus x plus 6. We're going to subtract 1 from the exponent, and then we need to multiply by the derivative of what's inside here, which would be 4x to the third minus 1, which is the derivative of x, plus 0, of course. So this would be the final answer. Now, this part right here is just for me showing you, so you don't need it, but you can see the 8 on the outside, leave the inside alone, to the 1 less power times the derivative of the inside. You're going to hear me say that in class all the time. It's going to be multiply the exponent, leave the inside alone, to the 1 less power times the derivative of the inside. Some of these need to be rewritten. If you look at number 3, we're going to want to rewrite this exponent as 9x to the third minus x to the 1/2 power. Okay, and then we're going to do our chain rule. Multiply the exponent in front. Y prime. We'll get 1/2. Leave the inside alone. 9x to the third minus x. And this exponent is to the 1 less, so if we take 1 away from a half, we have negative 1/2, right? 50 cents minus $1 is negative 50 cents. Times the derivative of the inside, and the derivative of the inside is 27. That's weird. I'm going to get rid of that 7. X squared minus 1. Now, some students will say to me, well, isn't there supposed to be an exponent out here? Not really. You're just doing the derivative of the inside. So it's kind of like cover all this stuff on the outside up, and now you're just taking the derivative of just this function right here, and that's what's there. All right, let's do one more. We've got trig in here. This one is not terrible. There's actually a part of the chain rule that involves trigonometry when this is not just an x on the inside, but we'll take a look at that in another lesson. All right, so we've got g prime of x, and if you want to go ahead of me, I think that's a good idea now, seeing what you can do on your own. Three halves times 6, so that's 18 over 2, which is 9. And we have sine of x. We're going to leave the inside alone. This looks terrible, but you get it. To the 1 less, so 3 halves minus 2 halves is 1/2. And then times the derivative of sine. Derivative of sine is cosine. I taught you this lesson last week when we were doing the derivative of trig functions. Was it Wednesday? So if you were not here on Wednesday, then you did not see the derivative of sine, cosine, tangent, and so on. So you could talk to some of your classmates and ask them. I think there was just 2 of you that weren't here. Okay, so this is chain rule. It's outside derivative, leave the inside alone to the 1 less power times the derivative of whatever's on the inside. I hope these 4 examples made sense to you. I'm going to stop the video now. You can try the backside. Actually, hold on, let me check. No, I got to do these 2 examples. I forgot. These 2 examples involve product rule and quotient rule that involve chain rule within it. So let me teach you these and then I'll let you practice. So here are examples that require the use of chain rule when applying the product of the quotient rules. You can see in first example here, this f of x, that we have 2 functions being multiplied. Right? There's a little multiplication dot in the middle there. And when you multiply 2 functions, you know you need to use the product rule. So the product rule says you take the first, multiply it by the derivative of the second, and then do the second times the derivative of the first. But when we do the derivative of the second function here, you notice that the second function is going to be a chain rule. So that part there, you're going to have to pay attention to. So f prime of x is equal to product rule. First, 3x squared times the derivative of the second. This is where the chain rule comes in. So the derivative of this function, right, if you kind of just cover this part up right here and just focus right here, the derivative of this function is 3, leave the inside alone, to the 1 less power, times the derivative of the inside, which is just 2. So all we've done here was the first times the derivative of the second. Now we've got to do the second. 2x plus 2 raised to the third times the derivative of the first function, which is just 6x. So take a look at that. This was a product rule with a chain rule inside of it. Okay, so that's kind of combining all the rules we've learned so far, and you got your power rules and everything else in there. If we look at the next example, this is a quotient rule. So this is low d high minus high d low all over low low. I know you like when I say that. So f prime of x is equal to low 2x and d high. So the derivative of this right here is going to be a chain rule. The derivative of the top is 3 times x to the 4th minus 2x. Do the outside derivative, leave the inside alone, to the 1 less power, times the derivative of the inside, which is 4x cubed minus 2. Write that 2 again. So this is low d high minus high times d low, and the derivative of the bottom is just 2. Oh my god, that was terrible. Hold on. I can't draw straight lines with this. All over low low. And low low is 2x squared. See, you still get to laugh at me even though I'm not there. All right, so this is product rule with the chain rule in it, and this is quotient rule with the chain rule in it. Not too bad, right? I think you guys can handle both of those things. So there's a couple examples here at the bottom for you to practice, and I'm going to make another video with the answers so you can see it. All right, good luck.